What we're going to do today is extend a little bit of what we learned yesterday and also give you a chance then to practice all of these ideas so you can get just that much better with logarithms. Now, remember from yesterday, if the log base b of a is equal to x, that really just means that b to the x is going to equal a. Because remember, logarithms are exponents. Now, interesting, we can actually find some new values of logarithms by using a matching of the bases idea, something you're going to feel like you did just a few lessons ago, but now we can do it with logs. So remember, if a log is an exponent, maybe we could say that this log is equal to some unknown exponent. That just means 4 to some exponent is going to equal 8. And now we have ourselves a nice little problem where we're trying to find what exponent we would put on 4 to get 8. Well, that's going to require some matching bases. That's going to require recognizing that the number 4 can be written as a base 2. And when we write it as a base 2, we're going to write it as 2 squared. Now, why did I write it as a base 2? Well, quite frankly, because the number 8 can be written as a base 2. And when we do that carefully, we'll write it as a 2 to the third. Remember doing this just a few lessons ago? So now I'm able to say that the exponents would be equal. Now I'm able to say that 2x would equal 3. And that, of course, means that x equals 3 halves. So back to our original logarithm, that means that this log, base 4 of 8, is equal to 3 halves. Pretty nifty, eh? We found all that by matching the bases. So how about the log base 27 of 81? Now, using a matching of the bases idea, we would say that 27 to some unknown power is equal to 81. Well, you're not expected to know that in your head. You're expected to think about making 27 and 81 have a matching base. So what base are you picking? Are you picking 3? Because 3 to the third is equal to 27. And 3 to the fourth is equal to 81. And again, we can say that these exponents would have to be equal. That means that 3x would have to equal 4, and so x would equal 4 thirds. That means that this log, base 27 of 81, is equal to 4 thirds. Because remember, logs are exponents. Maybe you feel like you want to try number 3. I encourage you to feel that way. See if you can set up a little equation and match the bases. Now you should be setting up a statement that says 8 to some unknown power of x would equal 16. Be careful as you match these bases. You don't want to use a base 4. You do want to use a base 2. You do want to say that 8 is 2 to the third. 16 is 2 to the fourth. That means that the exponents would be equal. That means that 3x would equal 4. So that means that our log is equal to 4 thirds, because logs are exponents. This looks a little more involved. We kind of have some extra numbers. Let's treat it the same way. We're trying to find the value of this log. So we could say that 4 to the x power is equal to, it's just equal to 64 to the 2.1 power. Now, don't figure out 64 to the 2.1 power. What I want you to realize is that we want to think bases. So all I really want to do is change 64. I want to change it to be a base 4. Now, if I change it to be a base 4, I'll have to write it as 4 to the third. I'll write it as 4 to the third. Now, I still have this 2.1, and here's where it all comes together. We can say that our exponents are equal. Now remember, these exponents, 3 and 2.1, they're going to get multiplied. So we do end up using a calculator a little bit here, and we can multiply those to be 6.3. Make sure you realize that that means our original answer, our original logarithm up here, is equal to 6.3. Maybe you want to try it for number 5. I encourage you to do that right now. You can push pause. Two to what power equals 32 to the 4th power? Now don't do something silly and say that x has to equal 4, but you could make 32 look a little bit more like the base that we have. You could make it look like a base 2. So 2 to what power is 32? And of course it's the 5th power. So what we have now is the ability to say that x, the exponent, would have to equal this exponent. Make sure you multiply those numbers and we get 20. That means that the log is equal to 20. Now, if you stuck around yesterday, you saw that I showed you how to use your calculator to find the log base 4 of 20. It turns out that it's just a simple division problem. All you have to do is take the log of 20 and divide it by the log of 4. So how do you do this on your calculator? Well, find your log button and take the log of 20 divided by the log of 4. And look, you get 2.161. Do you remember that number from yesterday? That was our magical exponent. Now, it's also the value of this log, but remember, logs are exponents. So what that means is that 4 to the 2.161 power is equal to 20. So what did we just do on our calculator here? Well, we did a simple division problem, and it's known as the change of base formula. Now, the change of base formula says that I can figure out the value of any log base b of a by simply dividing the log of a by the log of b. What I like to say is you always divide by the base. You always divide by the log of the base. So if we're asked to figure out the log base 2 of 50, remember, that means we're trying to find the exponent that we would put on 2 to get 50. But we don't know what that is in our head, and we're not able to just match the bases either. So we can use our calculator, and all you have to do is divide the log of 50 by the log of 2. Now again, make sure that you can do this on your calculator. Make sure that you're able to use the right buttons. And here I'm taking the log of 50 and I'm dividing it by the log of 2. Now, probably the main problem that kids have is they have to make sure that they close the parenthesis. That way you're doing the log of 50 and then you divide by the log of 2. So be very careful that you put both these parentheses in so that you're actually dividing the entire logs. And look, you should get 5.64, and if you round it, 4. 5.644. So that would be the value of this log, and it would also be the exponent. You want to try one on your own? The log base 7 of 80. You don't have to show any work. You can just use your calculator, and you should be dividing. And of course, be careful that you finish these parentheses so that you end up getting 9.644. Now, sometimes students will accidentally think that Mr. Neller told them that you always divide by the small number. And so sometimes students will just kind of accidentally do the log of 10, because that's the bigger number, and divide by the log of 2. But we don't divide by the smaller number. We divide by the base. And so when you do this division problem correctly using the change of base formula, you actually do the log of 2 divided by the log of 10. You have to actually divide in that order. Now, when you do that on your calculator, you should end up with 0.3. But I want to show you something kind of interesting here about logarithms and your calculator. You see, your log button on your calculator that you're using is actually defaulted to be base 10. What I'm saying is that we could actually do this problem by just doing the log base 10 of 2. Because when you use your log button, it's already in base 10. So if you just do the log of 2, it assumes that that's base 10, and look, you get the same answer as if we had divided. So you can do it both ways. Sometimes students want to be sure, and they'll always do the division that you can see right here. But what I'm saying is that if the base is 10, we don't need to do division because your calculator's log button is already in base 10. It already is the base 10. We actually call that the common log. It's the common log because base 10 is the most common type of base to have. So how are you doing this last one? Are you just typing in the log of 200? Because the log of 200 is already going to be in base 10. And you'll end up with 2.3. Now, this last box of problems down here at the bottom really reveals the purpose for logarithms. It's such a simple but special idea, kind of like the town of Felton, that if you drive through it and don't pay attention, you'll miss all the beautiful homes. So make sure you're paying attention because I don't want you to miss the purpose for logarithms. And quite simply, it's to find an exponent. You see, in algebra, when we want to find an exponent, we need logarithms. So do you see how you can write this equation as a log base 5 of 10? And look, it's equal to x. It's equal to the exponent. And you say, Miss Naylor, I'm not seeing it. I'm driving through Felton and I'm not paying attention. Well, look, the log base 5 of 10, you now know how to find that. You can find that on your calculator. You can find that with simple division. And when you do that simple division problem and you get this decimal, what you're really finding is your exponent. And so it's that simple. Logarithms help us to find exponents. So are you ready to find the exponent that you would put on 3 to get 90? Sound like kind of a familiar story? The exponent that you put on 3 to get 90 would be the log base 3 of 90. And yes, that's a calculator problem. Divide it on your calculator. Do the log of 90 divided by the log of 3. Pretty easy, right? It ends up giving you the exponent. And that's all there is to it. Why don't you try one? And if you're really rolling, you can try both of these. Now, number 3, I like this one because it's a base 10. Were you paying attention on the last problem? If it's a base 10, that's what your calculator's already programmed in. So that means you can actually just type in the log of 3. Now, when you type in the log of 3, you get 0.477. And in this last one, well, it's an exponent, so it's a log. It's the log base 6 of 60. And did you divide that on your calculator? You should end up with 3.570. Now, don't forget, when you divide the log of 600 by the log of 6 and you get this 3.570 number, that's actually the exponent that you would put on this base 6 to get 600. And so it actually works. The decimal, this value that you're getting, it actually is the exponent that solves that equation. Now, for a little bit of practice on the back of the paper, I'm going to ask you to work through these ideas, but I want you to follow the rules, especially in this first group of problems, because I want you to show your work, and the work that I expect to see is that you're matching the bases. In other words, you can't just type these in your calculator. You want to use the match the base idea. Now, you may use your calculator here, and you should be using your calculator down here. Should make quick work for those problems. Keep up the good work.